Okay, so I'm Victor, and today I want to tell you about managing state in Angular applications. It's a very different type of keynote compared to, I think, the rest of the event. It's very serious. There are no jokes. It's like, super hardcore, so be ready. So I used to be at Google, where I worked on the Angular team. I worked on Angular, and I built a bunch of key components of the framework. And I used to blog at Savkin.com. And some time ago, Jeff Cross, who is not here, and I, who is right there? Here you go. And I, right in front row. Yeah, but he's like, blends with the crowd, I guess. I don't know. Let's go to start our own company called Narwhal, where we help teams build ambitious projects with Angular. And these days I blog at blog.narwhal.io. So check us out. Check out our site to see what we do and how we work. Check out our blog and our Twitter to get high-quality Angular content. And also we have 3 books. One on the Angular itself, on the framework, the core framework. The other one, the second one is about the router, and the last one is about upgrading AngularJS applications to Angular. All right, so today I will talk about managing state, which is a vast topic. And I've thought a lot about it, and I've written a lot about it. So I decided to pick a small slice, like a very narrow slice of this problem of managing state that we all have to deal with, and cover this in this talk. So if you think I missed something because I'm going too narrow, grab me after the talk, and I'm happy to talk to you about that. So what I'm going to cover today is a bunch of things. The first thing I want to cover is the 6 types of state a typical web application has, pretty much any web application you look at. Then I will talk about the synchronization problem we have to deal with when we manage state in Angular apps. In particular, I want to talk about synchronizing the server and the client, and synchronize the client and the URL. Finally, I'll talk about a few approaches you can use a few patterns you can apply to sort of mitigate this problem. Before we dive into the content, let's look at the example that I'm going to use. This is an example. It's an app showing a list of tech talks that you can filter, watch, and you can rate them as well. It has 2 screens, so it has 2 routes. One shows the list of talks, and the other one shows an individual talk. It's a very simple app, but even this very simple app has 6 types of state. So the first type of state is the server state, which is stored unsurprisingly on a server, and is provided via, for example, a REST endpoint. So technically, it's not part of your web app, it's not part of your Angular app, but it's still important to understand it there because we need to deal with it when we're building our front applications. The second type is the persistent state, which is a subset of the server state. So naively, you can think about it, or you can treat it sort of as a cache of the server state. In real apps, that doesn't work because you often want to update your persistent state optimistically to make the UI responsive, to enable better user experience. But sort of think about it as a cache, or like a different replica of the server state. Then we have the client state. The client state is not stored on the server. So a good example would be the filters we use to create this list. So the items in the list themselves come from the backend, come from the server. So they are the persistent state. The filters we use aren't stored on the server. So we use them to construct the list, but we don't actually store them on the backend. There's a good practice to reflect both of those, the persistent state and the client state, in the URL. This allows bookmarking. You can copy a URL, send it to your friend. The back button behavior works. So if you don't do that, your application will feel broken. This means that we have another type of state, which is the URL, or the router state, which is some sort of structured representation of the URL. Next, most applications we deal with have also transient client state. So something we have on the client that we store, we persist, across, let's say, page refreshes, but it's not represented in the URL. An example would be if you have a YouTube video that you watch, and you navigate away, and you come back, you see that the video resumes from the moment where you stopped. It resumes in the middle. But if you send the URL to someone else, they're going to start watching from the very beginning. And finally, you have local UI state. So individual components or directives can have some local state governing small aspects of their behavior. So what should be the color of the button be? Scrolling position, stuff like that. So usually it's derived from other types of state, but it doesn't have to be. So pretty much any app you deal with on the web has those 6 types of state. And the biggest problem we have with them is managing synchronization. So why do we need to synchronize? We need to synchronize because the persistent state and the server state, they store the same information. So do the client state and the URL. So basically, we have multiple copies of the same information present, and as such, we need to synchronize them for our application to work properly. And the choice of the synchronization strategy or strategies that you're going to use in your application is probably the most important architectural decision you can make when designing your app. Like, can we make it synchronous? What has to be asynchronous? All this kind of stuff is very hard to answer in an ad hoc way. It needs to be thought through. All right, so let's look at one problem sort of in detail. The first one, which is syncing persistent and server state. To see what the problem is, let's imagine we have this class, backend, that we use to interact with the server. It represents the server, represents the backend. As you can see, it has a cache of talks. And in the interest of time, let's just assume we maintain that cache correctly. So I omitted the details about how we actually populate the cache, because it's a complex problem in itself. Just ignore that for now. Instead, let's look at the rateTalk method. The method is very simple. What it does, it takes a talk ID, and it takes a rating, and it applies the rating to the talk. It rates the talk. And it does it by finding the talk in memory, in the cache, then optimistically updating it, so our UI will reflect the change right away. So the app feels responsive, or is responsive, and then it submits, makes a post essentially to save this rating on the backend. Okay? The question we need to ask ourselves when we see this kind of code is, what if this request fails? Because at some point it will fail. You're going to a tunnel, or if you're far on a boat or whatever, your internet doesn't work as well as it should. It will fail. So what would you do? Because the code that we see right here on this slide doesn't handle the failure at all. So what will happen is, if it fails, the talk on the client side will be rated, and the talk on the backend won't be. So our application is out of sync, with the backend. Essentially, it's broken. So what we do, most developers, and myself included, we try to fix it in an ad hoc way. Because ad hoc ways are the way we approach most of our problems, because it's easier. And the easiest way I can think of to fix this issue is to attach a catch callback, or use a catch, to say, hey, if an error happens, I'm going to reset the rating back to null, because it means that it didn't persist in the backend, and then I'm going to rethrow. Okay? Which kind of works. It seems like it's working, but in reality it doesn't. Yes? And let's see why. It doesn't work because of the following issue. Imagine, hopefully you can see, but I will try to explain what happens here, is imagine we are trying to raise this talk twice. So we set the rating to 4 first, that's our first intent, our first request. So we fire the request to the backend. Then we changed our mind because the talk wasn't that good. We're like, let's set it to 3. So we have 2 requests going to the backend, and we didn't get responses for those requests yet. What may happen is, because we cannot control it, there is no imposed ordering, that the response for the second request will come first, for the one that sets to 3, and the response for the first request, let's say, comes second, and let's imagine the request actually fails on the backend. Okay, so we have an exception. What will happen on the client side is our talk will be reset to null, because we got the second response last, or the response for the first request last. So on the backend, the rating is happily set to 3, and on the front end, it's set to null. So again, we're out of sync, just in a different way. Our application is still broken. Yes, and it's broken because our solution was ad hoc, and ad hoc solutions do not work with distributed systems. We will see how to fix it in the second part of the talk. Now let's look at a different problem, syncing URL and client state. And lots of applications suffer from this. If you click back and forward like very quickly, you can see how most apps break, and you can see that the URL doesn't reflect what's shown on the screen. It's shocking how common it is. So to see why it is a problem, let's look at this component. So that's what happens right now in this component. This component shows or represents the list of talks and the filters. It basically represents the whole screen. It has an event handler, which is going to refetch all the talks every time we change our filters. So let's imagine, the problem rather here is that when we do it, we don't update the URL. So if you click around, the URL will stay the same. And if we refresh the page, all the filters and all the data will be gone. If we click on the back button, everything's going to break. We cannot pass the URL to our friend, because basically we don't reflect the state of the application in the URL. That's really bad. So we can try to fix it by saying every time we actually succeed with refetching the data, and we know that we've shown correct data, we are going to navigate to that URL, essentially by updating the location, or the location bar in the browser. So that's good. So at least we have the location set properly. Next, what we need to do is we need to read from that location in case you refresh the page. And we can do it again in an ad hoc way by subscribing to the params observable that the router gives us. We're going to listen to all params changes, and every time any of them changes, we're going to refetch the list of talks. So if you load the page, the data we'll see will be correct. So on the surface, that seems legit. Yeah? That seems like the component is fixed. If we try to update the URL directly, or if we refresh the page or go back, the data will be displayed correctly. If we click on a button in the UI, the event handler will be called, and again, the data will be displayed correctly. But because we saw what happened last time, exactly the same thing is going to happen this time. If we try to do a lot of modification at once, for example, if we try to switch our filter from A to B very quickly, before we got the response from the backend, we may have a system that's broken again. Why is that? We can have it if the second response comes first, or the response for the second request comes first. If it happens, we will see the filter showing B, but the list of talks under the filter will contain A. So application is broken again. So why is it so hard? Yeah, so we made a few ad hoc fixes, and if we try to run unit tests for our apps, for this application, we will see that the unit tests will pass. And the reason why they pass is because unit tests don't surface race conditions. And those race conditions are very hard to fix in this ad hoc fashion. And they're the result of us not thinking through the state management of our application in a careful way. And most web apps suffer from this. If you go to any bank, online banking, if you use online banking, click back and forth, and shit will fall apart very quickly. It's nothing to do with Angular. It's nothing to do with Rx. The fundamental issue of distributed systems, and any front-end application that talks to the backend is a distributed system. More concretely, that's what we did wrong. We did not separate the state management of our application from side effects. If you look at the backend class we had, it does everything. It talks to the server, manages state, runs some computation. It's really bad. We didn't clearly define the sync strategy of the persistent state and the server. It's very ad hoc, and it's buggy, as we saw. We didn't clearly define the sync strategy of the client state in the URL. It's ad hoc and buggy, once again. And finally, our model is mutable. So the model we use to represent the state of our application that we share across components is mutable, which makes ensuring guarantees very difficult. So let's try to address these problems. And we're going to start with clearly separating the state management from everything else, in particular from side effects. So this is what we ended up having when we tried to fix the backend class in an ad hoc way. It's very tricky to straighten it up, to fix it properly without separating the state management and the side effects, because it does everything right now. The reason is why it's hard to fix this class, because state management is very hard. It's probably the hardest thing you can do in your app. So lumping it together with anything else, with side effects or computation, talking to the server, will create unnecessary headaches. A lot of, I actually mean a different type of egg, but headache is so it creates a lot of headache. So we want to separate them to avoid that. And there are many ways to do it. I'm going to show you one way, just sort of as an example. But of course, you can choose a different route if you have a different preference in your organization. What I'm going to do is I'm going to introduce NGRX into this application. I'm not going to cover it in detail. I just want to sort of explain what it does roughly, how it works roughly, and why it is a good solution. Now, there are two key components to NGRX: store and its reducers, and effects classes. Store, or rather its reducers, is responsible for managing state. So what happens is our components just dispatch actions, basically indicating intent, saying, I want to do this. Store would listen to those actions and would create new copies of state, reflecting those actions applied. effects classes can listen to those actions as well and perform necessary side effects to make sure that our application is consistent. For example, they can talk to the server to make sure the server reflects the state that we see on the screen. And at this point, the backend class doesn't do anything interesting. It's just a stateless wrapper around HTTP. So once again, two key components, store and effects. Store manages state, and effects classes perform side effects. That's what our backend class looks like right now. As you can see, just a thin wrapper around HTTP. In many cases, you can just inline it. You don't have to have it at all. So store is built of reducer. That's an example of reducer that our store would be built of. And what reducer is a function that takes the current state of our application, takes an action, which is an intent, something we want to do or the user wants to do, and creates a new state out of it, like a new copy of the state of our application. And an action is something that has a type, indicating what it is, and some sort of payload. And the payload is just some extra information we need to perform that action. That's one of the reducers we have in our application, and it implements the rate action. So what it does, it tries to find the talk in the state, so like the in-memory object. It creates a new copy of this talk, a new copy with the rating applied. It creates a new copy of the collection where the talk is, and then it creates a new copy of the whole state. Okay? It's important to stress that we do not mutate our talk anymore. So we create a new copy of everything, so we use immutable data. It is important to keep this kind of data, what we store in the store, or we have in the store, immutable because we share it across multiple components, or even we share it across client-side and the backend. And as such, if you have it immutable, it's just easier to ensure that the state remains consistent. That everything that we have is in the right place. And it's easier to ensure lots of other things. For example, undo things and do all sorts of like reverts and rollbacks. Local UIs that you have in your components, like the color of a button, the scrolling position, that can be mutable. It's fine. Nobody cares about that one. It's never the main source of your issues. You can do whatever you want with that one. The shared one, the one you're going to share between components or between the client side and the backend, try to keep that one immutable. Also, it's important to know that here it's a little bit verbose. So it's 4 lines of code to create a new copy of the state to essentially apply the rating. And it's verbose because I do it without any extra facilities. I'm just like doing it directly with JavaScript. If I use something like immutable.js, it will be much shorter to be a one-liner. So that's the store. Once again, it takes the current state of your application, takes an action, and creates a new copy of that state. Effects classes are slightly different, and the way they work is as follows. So here we have an effects class. It takes actions, which is essentially an observable, an RxJS observable, of all actions that are going through your store. Okay? And what it does is we're going to filter that observable to get only rate actions. To have a different observable with only rate actions. Then what we're going to do, we are going to make a request for each of those in that switch map. And what we do in there, if it succeeds, if the request is successful, we're going to do nothing. Yes, we're happy because we apply an optimistic update here. So we assume that if the server is fine, we are fine as well. If it fails, however, yes, if the server responds with an error, we are going to emit, or we are going to return that observable with an unrate action. Okay. Also note that I'm using a switch map here, and switch map allows us, to essentially to get rid of the trace condition. So that's how it works. That's how switch map works. Essentially, switch map, it's a very hand-wavy explanation, allows us to worry only about the latest observable, the latest request we're making, So the moment the second request is made, we're going to ignore, the first one, the first observable and the first request. And as such, if it fails, we do not care, So it really does what we intend to do. If we click twice, the first click, the result for the first click will be ignored. Okay, and we can apply this fix, and as you can see, switch map, a very easy fix, a one-liner. We can use it, we can use switch map to fix this race condition, to fix our application only because we have a single observable for the same type of actions. If we have an observable of all rate actions happening in your application. We didn't have it in our original design. So we couldn't apply the same fix in our original design because we would have an observable per click. Yes, and we wouldn't have a single observable representing all the rate clicks. Okay? So we couldn't fix it ad hoc. Finally, we modified our reducer to say if the backend fails and if we return an unrate action, we are going to modify our state accordingly. So we are going to find the same object in memory, create a new copy with the rating set to null, create a new copy of the call collection, and create a new copy of the state. Okay? That's what it's going to look like. So when the user clicks on the button, what we are doing is we are dispatching a rate action. Our reducer and our store is going to use that action to create a new copy of the state with the talk rated. Then our effects class is going to talk to the server to make sure it's rated over there. And if it fails, we're going to dispatch an unrate action and then do our state modification. So in general, this is a very good rule to follow, which surprisingly very few people follow, which is optimistic updates, which is most of our updates. If you build web applications, chances are most of your updates are optimistic updates, unless you build hardcore financial software where it may not be appropriate all the time. Optimistic updates require separate actions to deal with errors or with failures. So don't try to patch it up in place and pretend it didn't happen, yes? Because the user who was interacting with your application saw the value changing back and forth. And because the user saw that behavior, the rating and unrating, should enter the domain language or the ubiquitous language of your application. So when we use NGRX, we represent this language through a set of actions. So you just add a new action to reflect this behavior. If you don't use NGRX, you can have other ways to do it, but you still need to reflect it in the language and in the domain of your application. So let's see what we got. So we apply this, this change. The result is actually pretty good. Yes, we have state management and side effects separated. Two separate classes, two separate entities. So we can deal with state in one place. We can deal with side effects in a separate place. We have a clear undo strategy, which is pretty good. Because we use switchmap, you don't have to use switchmap. That's not the only solution. But because we use switchmap, we actually managed to get rid of the race condition. Our application finally behaves properly. So everything is in the right place. Everything is separated, side effects, UI, and state management. And so all the concerns are separate. And all the issues we had are gone. So our application finally works properly. One thing to note here is that I used NGRX, which implements the Redux like way of managing state. But my goal was not to use it. So it's easy to use NGRX or Redux if you're in the React world, and still screw it up. Still mix everything up, use mutable data, do not have a good strategy to unrolling optimistic updates and stuff like that. So NGRX gives us, allows us or enables us to do that, to fix all these issues. But it's not the only solution. You can still screw it up. So nothing can replace your thinking carefully about how to do it. OK, let's look at the other problem, which is syncing the URL and the client state. OK, that's what we had. If you remember, I've had this component which kind of worked, but we know it didn't. Yes. So the first issue we want to address here is that we have actually two ways to update our local cache of talks. So we do it once in the event handler, and we do it second time in the constructor. And it's unfortunate. Just having more than one way of doing things is just, again, unnecessary headache. To fix it, we need to apply this rule. So we need to always treat the router or the URL, the location, as the source of truth and the initiator of actions. So in other words, the router or the URL change has to invoke the reducer or cause a state change, not the other way around. So why is that? Because people do it both ways. It is like that because the user can always interact with the URL directly. It's a web app. It's not a native app. So you can always update the URL directly. And as such, you have to handle this use case. You just have to. So you might as well make it the only use case you handle. So we can do it like this. We can just say, hey, if you change the filter, what we're going to do is merely navigate into the new URL. And then the constructor will fire that callback, the subscribe callback, and we're going to reflect the change by fetching all the right talks. That looks reasonable. At least there is no duplication. The next issue that we want to fix here is that it kind of works, but the component has intimate knowledge about how the list of talks is constructed. Because it essentially says, I know that the list of talks is constructed based on the parameters in the URL. And there is nothing else that can affect it, because we are not listening to anything else. So having this intimate knowledge, this information is hard-coded in this component, is very unfortunate. So we want to remove it and make our component as simple as possible by essentially letting it do two things. It can initiate actions to navigate to new URLs, and it can listen to state changes. But it shouldn't know how that state or how those state changes come to be. That's what we want instead. Yes? What we want is we want to have a store injected, and we want to just say, hey, I want the list of talks from that store. How exactly it's constructed, I couldn't care less. This component is as simple as it can be. It has two one-line functions. And if we apply this change, the interaction is going to look as follows. Okay? Our component, when we click on some sort of filter, is going to invoke navigate. So the router will take this navigation, it will execute it, and will update the location in the browser. Store and effect are going to listen to that location change. They're like, oh, something changed in the location. Interesting. They will pick it up. They'll figure out what it is. They're going to update the state in the store. Then that component in the constructor is going to see that update. It's going to receive a new set of talks, and it's going to display it. Okay? Let's look at it a little bit more sort of in depth. So we have this component, same component, just remove the constructor. And here I'm calling navigate. Because in GRX and the router, they are integrated with each other, when I call navigate, or when I update the location in any other way, the router is going to invoke or dispatch an update location action. So we are going to have an effects class that's going to listen to that action. It's going to listen to all location changes. And for each of them, it's going to invoke the backend to fetch the new list of talks. And then we're going to map it to a different action. Update talks with a set of talks fetched and probably parsed in some way. Note again that I'm using a switchmap over there, which means that I'm not going to have that race condition we discussed before. And then that was the effects class. Basically, it listens to the location change, gets a list of talks, dispatches a different action. And then some reducer is going to listen to that action, and it's going to create a new state with this new set of talks. Okay? And after this reducer is done, a new state will be emitted from the store, which this guy, this component, is going to pick up and is going to display. Okay? Note how simple this component is. Yeah, there are only two things this component can do. It can navigate or dispatch actions, and it can listen to state changes. It's very nice. That's how interaction works overall. So there are two ways to interact with our app. We can do it via the URL, which is always the case, and it's almost always broken in web apps. Or you can interact with it directly, if you just click on buttons and stuff. So regardless of what you do, we are going to dispatch an update location action, or rather the router is going to do it. And then our backend is going to fetch the talks. Our effects class is going to transform that thing into a different action. Our reducer is going to pick it up and create a new state. Okay? It's really cool. So what did we achieve? Why is it good? Because it may seem a little bit more complicated at first, but it's actually good in a few ways. The first one is the updating the location, updating our UI updating the list of talks via the UI or via the location are implemented in the same way. So we have one way of doing stuff, which is always good. Our component is as simple as it can be. So components get simpler. And components tend to be the place where a bulk of complexity of your application lives. So the simpler they are, the better, because they're the hardest one to test. Because we use switchmap, we no longer have race conditions, which is very nice. Our application finally behaves in a consistent way. We can click back and forth, we can update the location. It will always display what it's supposed to display. So everything is in place, everything is clearly separated, and all the issues we saw are gone. Okay? What is the summary? So what we have, what we started with rather, is a very simple app. So it's a very simple application. It looked very reasonable. All the functions were very small. The code looked well written, So it looked like it's a good app. It's not a monstrous app we saw day to day while working on our enterprise apps. But when we examined it closer, we saw that it is broken in many ways. So we tried to fix the app in an ad hoc way, and we fixed some of the issues, but not all of them. And the reason why we didn't fix all of them is because our fixes were ad hoc. Not a holistic solution to manage state, just a bunch of ad hoc fixes sprinkled around. And those issues that we saw are not Angular issues, or not only Angular or RxJS issues. Any web app, you can use Backbone, Knockout, React, Vue. You have the same set of issues. Those are universal because those are the issues you have when you deal with distributed systems, which is any web application is. That's because when you talk to the backend, it's a distributed system. So to fix it, we need to think through our state management strategy and do it in a way which is done carefully. So we did it. We refactored our application to use NGRX and immutable data. And then we made the router the source of truth. And suddenly all the issues were gone. The changes were not drastic, we changed it a little bit, and suddenly our application is predictable, behaves in a very nice way. It's actually more testable as well. The main takeaway here, though, is not to use NGRX or just apply the same stuff over, or use switchmap everywhere, but rather that managing state is very hard. It's the most painful thing you have to deal with, and as such, it requires careful thinking. So if anyone is telling you, hey, I just have this new approach, something library that fixes it for you, it's a liar. Just discard this statement, think it through. Chances are something's going to break. There are trade-offs. So careful thinking is the message that I'm trying to spread around. OK, if you want to learn more, check out our blog. It's pretty good. Everything there is free. Also check out our books. Those are not free, but if you talk to me in person, I can give you a copy for free. Hey. And check out that article. It's basically the same stuff, the same content, delivered in a slightly different way. Thank you so much.